Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for running your next app or experimenting with something you hear about on the show. You can visit the site at www.podcastinit.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. And to help other people find the show, you can leave a review on iTunes or Google Play Music, and you can also tell your friends and coworkers or share it on social media. Your host as usual is Tobias Macy, and today I'm interviewing Erik Rose and Dave Beazley about what parsing is, why you might want to use it, and how their respective libraries, Parsimonious and Ply, make it easy. So could you each introduce yourself? How about Dave? You go first.
All right, well, I'm Dave Beazley. I'm sitting here in Chicago. People probably know me from maybe the Python Essential Reference Book and the Python Cookbook.
And Erik, how about yourself?
Well, let's see. I'm Erik, and I sit in my glacially carved fortress in North Carolina, where I work remotely as a language wonk for Mozilla. And I'm really interested in the intersection of formal languages and human cognition, and have been for some time. And at Mozilla, I make a little tool called DXR that is a search and analysis utility for large code bases in various languages. I work on Fathom, which is a language for teaching web browsers how to understand pages like web pages like humans do. And on the side, I make an eclectic venting of Python libraries.
Starting with you again, Dave, how did you get introduced to Python?
I actually got introduced to Python through parsing, believe it or not. That's sort of a weird story. So I came into Python through scientific computing, and I had taken a compilers course as a grad student, and I got this idea that, boy, it'd be kind of cool if I could build my own version of MATLAB or something to control this big physics code. Went off and actually wrote my own scripting language, and then went back to grad school and was like immediately scorned. They're like, "You idiot, why did you make another programming language?" And then they're like, "Why don't you use something that exists?" So I kind of went around and looked at different things like Tickle and Perl, and discovered Python in the process of that, and was actually working on the Swig project at the time. So people have heard of Swig. That is basically a parser that takes C and C++ header files and makes extension modules out of it. So that's where I discovered it. I was working on parsing from the beginning there.
And Erik, how about you?
Oh, well, I also got into PyCon through kind of a weird series of events. Through not really knowing how to interview, I ended up writing VB script code over at Penn State. And I had been a collector of languages for some years, and a couple dozen to my name. And I said, I'm going to give VB script a chance. And I gave it about a year. And then I finally realized that you can't actually write anything in VB script. And so I started looking for escape hatches. And fortunately, there's this wonderful Microsoft artifact called the Windows Scripting Host that sits around and runs VB script and also JScript and also other languages like Python. And you can bridge between languages on Windows Scripting Host. And so I was able to take Python and kind of cram it as a sidecar onto the VB script project and escape from the VB script wonderland, where you can have classes but not subclasses and other horrible things. So that's how I got into Python. And well, I've been on it ever since and jettisoned VB script, good riddance, and here I still am.
So can you start by talking a bit about your respective libraries and the problems that you were trying to solve when they were first created? So Dave, how about you go first again?
All right. So, I have this Ply library, and maybe a bit of an interesting story on that. So, as I noted, I originally created this Swig package for doing C and C++ extensions. And one of the questions I always got with that package is, why was it written in C++? So the Swig package is written in C++, and the parser is written in C++, and so forth. And the reason it was written in C++ is that was what I'd learned in graduate school. I mean, I wrote a compiler and used Lex and Yak, which are these Unix tools, and that's what I knew to how to write things with, and that's why I used it. But as a Python programmer, people started asking me, it's like, why don't you just write this in Python? Like, why are you punishing yourself by writing this tool in C++? And the answer to that is, at the time, keep in mind, this would have been like 99, year 2000. There actually were not a large number of parsing tools available in Python. It certainly wasn't anything sort of comparable to the Unix sort of Lex Yak toolkit. And I honestly didn't know how I was going to, how I would undertake such a project without that. So through kind of a weird sort of turn of events, I had an opportunity to teach the compilers course at the university. Turns out the prior professor didn't get tenure and disappeared. So this opening opened up, and I sort of took the compilers course over. And as part of that, I said, you know what, I'm gonna do this in Python. Let's find out what it's like to write a compiler in Python, and ended up having to write like a Lex Yak tool over spring break. So it turns out that the original version of Ply was written in like 10 days over spring break for the purpose of doing a class. Since then, it's been about 16 years of debugging. So but we'll talk about that later. But that's where it came from. It was like, just, I need to have a tool. There is no tool. Let's just do something and, kind of see what we can get out of it. So
that's actually one of the things that I admire most about Ply is you've basically put it through the worst debugging ringer imaginable, which is class after class of students. And so it has this fantastic error behavior and error output. My own library, Parsimonious, got started because, well, I was working on the Firefox support website. And because of hysterical porpoises, we had a love for the MediaWiki grammar. We wrote all of our pages in this, well, I guess it was basically stock MediaWiki. And we had a MediaWiki library off to the side that David Kramer had ported over from the original PHP. It was like a straight transliteration. It still had dollar signs in the comments. And the problem came when we wanted to shoehorn some of our own control structures into that existing MediaWiki syntax. We wanted to do things like make notations so that if someone came up in Firefox 3 and looked at the page, they'd see one thing, but if they were in Firefox 4, they'd see a slightly different set of instructions, let's say. And trying to cram that thing into the existing kind of MediaWiki port code was just offensively ugly. The way that MediaWiki worked at the time was by running something like 41 regex find and replace routines, just one after another, sticking tokens in there and running some other replaces, and then trying to go replace those other tokens and trying to keep these different replaces from stepping on each other's toes. And then on top of that, there was 2,000 imperative lines of code that kind of drove all this stuff and loops and horrible things like that. And so I set out to kind of as a research project, kind of as a practical thing, let's see if we can come up with A, a MediaWiki grammar in a formal sense, and B, a toolkit to run it on. Yeah, I went shopping, went through all these Python parsing libraries, and one of the things that drove me to write my own was that MediaWiki is not like an LR1 grammar, which is the technical way of saying it. The basic meaning of that is you can't quite tell what it is you're parsing until you look ahead more than one step. So a well-designed language like, Python, for example, you don't have to look ahead that far. If you say def, hey, you know it's going to be a function. If you say class, it's probably going to be a class. MediaWiki, not so much. Like the link syntax, you start with this square bracket, and then maybe a URL, and then maybe a title, and then you wait for that end square bracket. But hey, you know what? It's not there. We're just going to keep on trucking. And it turns out, well, that's not a link after all then, because the end square bracket didn't come when we expected it to be. But it was, again, more than one step ahead that we have to look to find that out. So Parsimonious was written to solve this problem. It was written to support extensible grammars. Parsimonious uses some theory called parsing extension grammars. That's the kind of grammars it supports. And those were introduced by a guy, Brian Ford, in 2004. And the nice thing about them is they're composable. So we could start with a grammar that represented MediaWiki, and then later plug in our little Firefox-specific nodules, and you still have a valid grammar. And I also wanted to modernize things. PyParsing at the time was kind of I considered what the standard thing was. And it's a single 3,000 line module. It doesn't, if I recall right, it didn't really have any tests at the time. And it's very hard to read a PyParsing grammar, at least to my eyes. And so parsimonious grammars look pretty much like what you'd find on a man page. So that pretty much covers my motivations.
I was going to say it's really interesting. It's almost like you have the super modern and the super old here at the same time. I mean, it's like the parsing, the parsing algorithm in Ply is straight out 1970. It's like it is. It's this thing. The LALR1 parsing algorithm, and I was basically trying to recreate, just exactly what is found in sort of the Unix tools.
Was that like for knowledge portability, so your students could run off and grab Lex and Yak and feel at home?
Partly, yeah. So, well, there's a lot of ththings written about Lex and Yak. There's sort of a known quantity. You can buy books about those.
Sure, got one sitting here.
And from like a sort of a pedagogical point of view, it was like we're doing Lex and Yak, not Yak plus or whatever wanted to do. So it was always meant to be like just a really just traditional look at things. And actually I think most programming language, you'll find like some implementation of Lex Yak kind of sitting around somewhere. I just happened to be the unlucky one to do it for Python. I don't know how that like fell in my lap. But
you did a good job, I think.
It's really hard to implement. I tried to, I mentioned it took like 16 years to debug this thing. There is actually not a lot of very good information on how to actually implement the LALR1 parsing algorithm. Like there's a lot of books that tell you how to use it, but actually putting it into code was like really hard to track down.
There's a book I have in my hands right now that I was using when I designed Parsimonious. I was shopping around for different things. Have you ever heard of Parsing Techniques by Grun and Jacobs?
Yeah, I don't know. Not off the top of my head, but...
It's a fantastic book. It's like where weird parsing algorithms go to die.
Oh, okay.
And it feels like it's 700 pages long, and it's just, here they all are, guys, and here's how to write them, and here's the theoretical behaviors of them, and the O notations, and everything you could possibly want. It's a great book.
See, I tried to implement it originally out of the infamous Dragon book.
Oh, yeah.
Oh, God. Yeah, for people listening, like if you're new to parsing, just go look up the Dragon book. This is like the book that you use if you want to weed out like half of your grad students. Just
if you dissuade someone from writing a compiler.
They'll just leave grad school. Just set them loose on the Dragon book. But I tried to implement it out of that, and I'm just not smart enough to figure that out. I ended up buying another textbook used textbook, I think from like 1978 or something. It was some very old book, and it actually had the algorithm in there in a very clear way. So ended up using that. But the Dragon book just exploded my head on the algorithm. I just don't know that there's that many people walking around who've actually had to put that algorithm into code. I mean, it's a very obscure thing. So.
For people who are fairly new to the idea of parsing, what are some of the ways that a full-fledged parser differs from what a general engineer would be more familiar with in terms of regular expression engines?
Well, I think the biggest way that it differs is that a vanilla regular expression engine can't deal with infinite nesting, arbitrary nesting. Good luck writing a vanilla regex that'll do, arbitrarily nested sets of parentheses or arbitrarily nested Python lists.
Or HTML.
Sure, that's a good example.
You don't parse HTML with a regex?
That's not if you value your sanity.
But I'm just thinking of that famous Stack Overflow answer. That's the...
You have to be careful to distinguish. Do you mean regexes, PCRE, whatever it is, or do you mean the academic idea of regular expressions, which totally can't do nesting? Now there are, Perl and maybe even Python abominations that stretch out regexes so they can deal with nesting, and that's a thing.
Yeah, talking more specifically about the implementations of regex engines that an average engineer might have been exposed to or implemented, and then decided that trying to figure out how to use a regular expression to do, as you said, arbitrarily nested syntax, making their head explode, and they want to turn to something that is more capable of actually solving that problem. So it's basically just sort of differentiating between what a full-fledged parser like Ply or Parsimonious is able to do versus what they might be trying to attempt to do with regular expression.
I generally say there are two things that should make you reach for an actual parser. One, you need to parse something you can't represent with regexes, like arbitrary nesting. And two, your head is exploding because your regex soup has gotten too big to deal with, even with, ignored white space and comments.
Yeah, I would jump in there too. I mean, for me, my background was not in programming languages, and I think like my experience in parsing, there's like this evolution where it's like, oh, I can parse command line argument. Okay, that's not too bad. Usually, it's like split things up into a list, and then maybe you can parse like a line of text where you have things separated by white space or something, and then you can sort of move up into things like XML or something. And you're like, well, maybe I could parse that, and then you get into if you get into like a real programming language, like, oh, I'm going to write a parser for Python, all of a sudden things start getting really hairy, really fast. You realize that, whatever you learn to parse like command line arguments is not going to cut it here. And it's that is where you start turning to these parsing tools.
When you find yourself coming up with all this imperative code wrapping around your salad of regexes, then it's time to think, this would be a lot easier to read and less buggy if it were in some kind of kit that lets me give it a grammar.
Yeah, I think parsing, like these parsing toolkits too, are often where a lot of students might first encounter like a real need to use tooling for stuff. I mean, I'm thinking back on my own background. I mean, it was, for a lot of stuff, it was always like, oh yeah, I could code that. It's like I can write something for the network, or I can do this. But then you get into compiler writing and you realize, oh man, this is like it's like at a whole level of complexity where almost the tooling is like, if you don't have the tooling, you're just dead, or it's.
What do you mean by tooling? Like Lex and Yak?
Yeah, like Lex and Yak tools, or like the parsing tools.
Yeah,
It's like if you don't have the tool, you're just.
The first step is to write the tool, then, like you did.
Yeah. I mean, it's so like, well, I mean, if for me, I was at the time I came into Python, I was writing a C++ parser. If I had to write a C++ parser doing a handwritten, like a recursive descent parser or something, I mean, that would be one of the most horrible things ever, probably. I mean, it was already bad with the tooling, but without that, it would be terrible.
Does that answer your question, Tobias?
Yes, it does. So, Eric, you mentioned the idea of being able to build a grammar for solving the particular problem set that you might be encountered with. So I'm wondering if you guys can dig a bit deeper into the sort of technical definition of grammars and how you might typically define a grammar and how that also gets consumed by the parsing tool to generate the desired output.
Well, I think of a grammar as just a formal way of describing the set of valid things in a given language. A grammar describes what is valid Python, what is a valid, maybe the little query language you're designing, down to the point where, how if you try to import just some garbage messed up module in Python, you'll get a syntax error right at import time. That's a sort of thing that a grammar will enforce. Okay, I don't get syntax errors anymore. Now, when I run it, it might still be buggy. I might get name errors. I might be talking about symbols that haven't been defined, but at least I can get it through the initial read-in and okay, it's a module, and I would know where to look for, this looks like a function, this looks like a function, this looks like a variable. Now away we go. I feel like that was fuzzy, so maybe Dave can defuzz it for me.
I guess I would agree with that. I mean, grammar is really defining kind of the structure of your program. I mean, or your input. Is this a valid input?
And so extracting a bit from that, it's basically the idea of setting the sort of tokens or identifying markers that will allow the parser to say that this is the start of a particular type of input, this is the end of a particular type of input. I can now extract everything between them to be this particular type of instance within the syntax tree that I'm generating.
It's a really good way to say it, Tobias, actually. Parsers are really, among other things that they do, input categorizers. Hey, this is a function, and this is an assignment statement, and this is something else. And then you've got your structure like, okay, this one contains that one, and this one contains those other ones. But yeah, they're at a high level, they're really kind of categorizers.
Yeah, I think that's a good description. Like in Python sense, like if you're assigning a variable or something, grammar would define, what can appear on the right-hand side of an equal sign. Not everything can appear over there. It's like you can't put like a while loop or something. So, a grammar would sort of specify that.
Yeah, you can say def whatever, but you can't say def.
At least not if you don't want to break your instance of Python.
Right. I don't think you can do that at all. I think you'll scream immediately. Now you got me wanting to try it. Def. Yeah, doesn't like that.
All right. Well, at least we've got that going for us.
One thing with grammar is I'm actually be curious to know how Erik's tool handles this. Is dealing with ambiguity.
Right.
In the grammar, it's like you may have multiple, this categorization, you may end up with syntax that falls into more than one category, and you get an ambiguous parsing situation. And one of the things with these tools oftentimes is how they deal with that, like that kind of situation. I think like having a tool where there's like more look ahead tends to better deal with that.
I never thought of it like that. But I suppose it would give you one more piece of signal.
Yeah, one example that I have seen of something like that where there is the ambiguity in terms of what a given token might represent is the Haunch tool by Anthony Skopatz, which is a hybrid of Python and Bash, and figuring out, okay, when you say ls, do you mean ls the shell command or ls this variable that you assigned? And I know that he's using ply as the actual parser for that, so he's created some additional syntax for being able to disambiguate some of those signals. So that's an interesting point that you made there, Dave, of bringing up the fact that by adding that look ahead, it might provide additional context that you can then use to interpret the original meaning of the first token that you encounter.
So one of the things that differentiates PEGs from a lot of other methods is it's really good at disambiguating things. It always comes up with an unambiguous parse. And that really comes down to its OR operator, its alternation operator. A lot of, reading EBNF, you'll see something vertical bar, something vertical bar. Well, PEG kind of tilts at 45 degrees and uses slashes as the convention. And the reason it changes the look of the operator is that it runs it all the time from left to right. First look at the leftmost one. If that doesn't work, try the next one. If that doesn't work, try the next one. And thus it deals with ambiguity. It gives you the leftmost happy recognition of the text you give it.
And when you're reading in the input for the peg parser, are you reading in the entirety of a block of text before it resolves the parsing step? Or are there particular checkpoints within a given parsing where you can say, okay, I've definitely closed this loop. Now I can sort of free up that block of memory to continue doing the parsing? Bringing that forward, is there the risk of hitting a memory limit for being able to consume the entirety of the input before you can generate the data structure that gets output as that parsing step?
Tobias, you have asked a tremendously penetrating question. So the weakness of peg parsing is, since it's not from the 70s when we were short on RAM, it goes ahead and blows memory proportional to the grammar size times the input length at maximum. And that's in the case where you don't close any of those loops, as you said. You're reading along, you get to the second last character. Oops, the last one doesn't match what I thought I was doing. Rewind the whole thing and start over again. That can totally happen in a vanilla peg. Now, let's see, if it's 5 years old, is it still a research problem? I'm going to say it's still a research problem. It's a solved research problem. You can embed in peg grammars, though not yet in Parsimonious, things called cuts, which mean, okay, well, if I've got this far, I am committed to such and such a production. I'm committed to this being a while loop, for example. And so I can throw away all those, partial parses that I've cached along the way for speed should I have to rewind and continue on with my while loop parsing. And incidentally, that's also a great place to park your error reporting. Okay, I've committed to this being a while loop, so if something makes it not a while loop, I can say, hey, I was totally committed to making a while loop out of this, and I was expecting one of these things, but I got one of these things, so go fix your program.
Yeah, I'm not that familiar with peg parsing, to be honest. How does it compare to something like early parsing?
Early was the other candidate, which I am now really rusty on. So you can generalize what early was again before I can find it in my parsing techniques book, and I'll be able to answer your question.
Well, I'm not an expert on early parsing either, except I will say that one of the big inspirations for Ply, or at least the way that it works, there was another Python programmer, John Aycock, who I think he's a professor up in Canada somewhere right now. He had this toolkit, Spark,
yeah,
which kind of worked in the same way that Ply did, except it used early parsing as its algorithm. And my impression of that is that it could basically parse anything without, it would resolve this ambiguity problem, but it had like these tremendous scaling issues. Like I'm probably getting this wrong, but it was like scaling like n cubed, where n was the number of input tokens or something. It could potentially have like a huge memory footprint or performance hit.
Well, that must be one place where they differ, because this tops out a little better than that. It's just, it's the grammar size that's really it's linear. It's linear in grammar size times input length. So yeah, it's not nearly as bad as n cubed.
Okay. Keep in mind, I'm trying to remember from like 15, 20 years ago. But yeah, I remember it had very different scaling properties.
And when I was doing Parsimonious, when I was shopping, I remember looking at Spark and pulling it down and looking at the early parser in there. And I don't remember, and I looked at my piece of notebook paper, I don't see why I didn't choose it. It might have been something cosmetic even, who knows.
I'm kind of wondering whether Spark was the inspiration for ultimately getting like Python decorators or something. One of the most genius things about that I remember was the horrible abuse of doc strings. So John came up there at the Python conference, and he's like, "Yeah, I embedded the grammar into doc strings." And then he did all this.
Didn't you do that in?
I copied it off of him. I went to PyCon or the Python conference. I saw that. I was like, "That is just so diabolically awesome," and I stole it. No, I took the idea straight into Ply, and this predated even like function attributes and other stuff in Python. And I think like they added, I think maybe the motivation for function attributes and maybe decorators and stuff later on is to get people to stop embedding hacks into doc strings. Once you unleash that, on the world, it's like, oh yeah, we could abuse doc strings and put all sorts of cool non-documentation stuff in there.
You want to know something else funny? I think I've gotten at least 2 different pull requests for Parsimonious to start sticking bits of grammar into doc strings of the visitor procedures. It's not a bad thing. It's not a bad thing unless, of course, you want to get two different results out of a parse. You get this tree, and then I want to render text out of it, and also HTML out of it. Well, then you're kind of hard coupled together, and it's no fun anymore.
So once a grammar has been consumed along with the input to the parser, what does the data structure look like after the parsing run has been completed?
It's just a nested list. It's a tree of some kind.
Mm-hmm.
Do you want to hear about the individual libraries, or just kind of in general, it's going to be a tree of some kind?
Yeah, in general, but also, I guess, more specifically, once it has been parsed and you do have that data structure, what are some of the ways that you might work with it to then be able to transform that parsed input into some form of logical output, whether it's rendering it as text or, in particular for things like where you're trying to build a DSL on top of an existing programming language, being able to render that parsed tree into logical operations.
Oh, this is where all the fun begins.
Yeah, I guess there's a lot of things you could do. I mean, you could do type checking. This would be more like program validation stuff. Is this? I mean, just because you've parsed it doesn't mean it's a valid program. So you can get into all sorts of program checking things. Does it take you in the direction of maybe like linter tools? Pie checking tools, that sort of stuff.
You could do optimizations. You could do tree transforms. Hey, these are adding two constants together. Heck with that. Merge them and just put a single constant in there. You could flatten it back out again if you're wanting to say, maybe you're trying to pretty print a program. Maybe you're trying to change something from wiki syntax over to HTML or something like that.
Yeah.
So it sounds like at this point it's largely up to the individual user to determine how best to actually use that data structure, and it's from that point on it's in others' hands and best left to other libraries or techniques.
Well, what can't you do with a nested list? What can't you represent with a nested list, really? I mean, just look at any Lisp, right? And just here's a Turing complete whatever you want as nested lists. Enjoy yourself.
Yeah, speaking of which, there's actually a Lisp that was implemented on top of the Python VM called Highlang that I did an episode about a while back that was pretty interesting to hear about some of the things that they're doing with it. Like, I know that the creator of the project actually managed to use Lisp to backport the yield from capabilities from Python 3 to Python 2.7.
Okay.
Yeah.
So High is a nice hack.
Yeah.
I
mean, the only thing with the list people though is if you really want to get their ire is talk about the problem of recursively navigating a nested list if it gets too deep. That's one thing in Python, not very good at recursion. If you make a giant parse tree and it's too deep, you could blow the recursion limit.
Right. Actually, I plan to play with this. I haven't done it yet, but so Parsimonious, being a recursive descent parser, can run into those recursion limits. I mean, you'd have to be parsing something fairly pathological, but hey, who knows? It can happen. And so one way around that in Python is you do some kind of trampolining, where instead of functions calling functions, your function goes one level deep and it kind of returns the next function to call to its caller, and then it just kind of calls that thing you returned. You just kind of bounce around in this one loop. And a nice side effect of that, as well as blowing the recursion limit, is it also gives you speed ups under something like PyPy, which has a JIT that only kicks in after you've spun around a flat loop 100 times. Like Parsimonious under PyPy, it doesn't go that much faster, 2x, 3x speed up. You turn this thing into a trampoline loop, maybe you get your 10x speed up.
Wow, interesting. Okay. Yeah, I did something like that in the cookbook. The other one way of traversing parse trees is use variations of the visitor pattern.
Sure, which is, Parsimonious throws one of those into the box.
So I got this idea in the cookbook. It's like, I wonder if I could write like a non-recursive visitor pattern.
Yeah.
Using generators.
Sure.
This is kind of the same idea, and it's this completely insane recipe. I mean, people will know it if they find it, but it's like non-recursive visitor pattern with something. It works. I feel a little bit sorry for anybody who would just wander into that recipe. Actually, the publisher at one point wanted me to put difficulty grades on the different recipes. Kind of like ski slopes. Like you have the beginner slope and the intermediate slope and the advanced slope, and it just sort of never happened. So none of the recipes in there are actually marked with any difficulty levels. I feel sorry for anybody just wander into that one.
Would it have been a double black flaming skull slope?
Oh yeah. It's insane, but it's kind of cool. I think it may use the trampolining thing or some variation of that, but
yeah, any variation of hold your own stack on the heap would suffice.
Yeah, it's too bad I didn't write it now, because then I could have dropped async and await on it or something.
I
really made it really confusing for somebody.
So for people who are interested in using a parser or developing a grammar for their own domain-specific language, or even an alternative language implementation on top of something like Python, what are some of the considerations that they should be aware of while creating that grammar?
I think they should probably think about whether their grammar is like a programming language or whether it's more like a natural language. Maybe that's not a very precise thing, but like a tool like Ply is very much geared at programming languages. Does it look like C or Java or something like that? That's what it's really good at. If you get into more like, I don't know, like natural language things, like parsing English or something, probably is not a good tool for that.
Right, yeah, well, if somebody's building a DSL, I would hope that they're not trying for an overly natural language type tool, but I know that, for instance, like the Gherkin syntax from Cucumber, while it is using English terminology, there is a certain structure to it, so I imagine that you could potentially use something like Ply or Parsimonious to actually turn that into something that's able to be interpreted by a computer program.
One thing I consider is, do you need to run in a RAM-restrained environment? Does your compiler need to run on an embedded system or something like that? And if so, watch your look ahead. Make sure you design your language such that you don't need to look ahead more than one token. Then you can use LAR1 parser like Lex or Yak or like Ply. Another consideration is try to disambiguate your construct as early as possible, so that as you're parsing, you don't have a lot of rewinds. You don't have a lot of wasted time in your parser going back and, it didn't work. Let me go back and try to interpret it a different way. Which is basically the same thing when you write regexes, right? If you're trying to write an efficient regex, you kind of put the high entropy stuff up first and say, well, it's not one of these character classes, so it can't possibly be this next token that's after my alternation. And then the other thing I'd like to think of is try to have a good convention for white space. Now, once you've designed your language and you're trying to actually lay the grammar out in formal syntax, what do you do about white space? Well, there are some parsing kits which will just ignore all white space for you, which is fine if you're writing kind of a run-of-the-mill C-like programming language. But if white space means something like, I don't know, kind of not like in Python, but if you're actually caring about white space to convey some semantics, you may want to preserve it in your grammar. And like with PEGs, I like to hang the white space off the right side of my leaf nodes. And then at the root node, put a little white space absorber just to the left. And that makes it all work perfectly.
And what are some of the most interesting or innovative or downright scary uses of parsers that either of you have seen, whether it's Ply or Parsimonious or any parser from another language toolchain as well?
One interesting use I have seen is using parsing toolkits to parse network protocols.
I see that done with Ometa, yeah.
Yeah, that's kind of you could potentially do something like that with Ply, actually, like hook up, like you write a grammar but you can often describe like a network protocol in terms of a grammar.
Why not? String's a string.
And then run it through something like Ply. That actually works reasonably well for something like an LALR1 parser, because it's just basically just one token look ahead, and it's just kind of sweeping through your data. So I've certainly seen that.
I mean, I've seen the inverse. I've seen the thing turned upside down and made a generator. There was a guy who went to music school, same time I did at Penn State, and he churned out a thing that created novel 12-tone music pieces from a generative grammar. I mean, my favorite kind of grammar bonanza, parsing bonanza, is Lisp, which barely needs a parser at all. It practically is a parse tree on the screen. And of course, the power you get out of that is, well, you get all the synergies from your program being the same as your data structures, and one of those is your program has become easily self-modifying. Write these wonderful Lisp macros that take in something that looks like Lisp but might be a DSL and just kind of tweak it and turn it around and turn it into valid Lisp, and that goes and you make machine code out of that. It's much more trivial than trying to, read Python code and then I have to lex it and then I have to get it all structured again and then I can do my job.
I think parsers can often show up in really unusual places too. I had coffee with somebody, I guess a year ago. I don't know. It was somebody who he had taken a course with me and we'd done some parsing stuff. He's like, Dave, I need to buy you coffee. So had a coffee, and he told me about how what he learned doing the parsing stuff helped him write code that was used to save the healthcare.gov website. I was like, really? I'm not remembering all the details, but that one of the issues with that healthcare site is that I guess they had like all these entities trying to talk to each other, and it was just like this communication like nightmare of stuff. And he said he was using some parsing tools to like basically grab data and sort of massage the data into standard formats and other things. So it's not even like programming related. It's using a parsing, some kind of parsing tool to parse like health insurance policy data or something. So it kind of blew my mind. Never would have occurred to me that what he learned programming, like a programming language, would apply to that. But
kind of being a programming language wonk, I do fall into the hey, parse it and you're done rut. But parsers are a big part of natural language processing as well. I mean, I'm not sure how part of speech tagging works, but it must be something like running parsers across sentences and then they fail and then you make a different guess about what kind of part of speech that must be.
Well, I know, too, that a lot of times when you're doing parts of speech tagging, the first thing you'll do is run it through a stemmer where you're stemming the words and figuring out the word roots, but basically where you have the beginnings of words that are similar with different endings depending on if it's a plural or singular form or things like that.
Run and running and ran.
Right. And once it's been stemmed, then a lot of time to be able to figure out parts of speech tagging, you'll use sort of the grammar syntax of the language where, for instance, in English, the verb goes before the noun. And so then you say, okay, if this happens and then this happens, then this is probably the subject of the sentence. And then also using punctuation to determine where the sentence boundaries are. That's essentially where the parsing comes into play, where you say, okay, this is punctuation, so that means that this prior token has this particular meaning, or this was recognized as a verb, so that means that the next thing is a noun, stuff like that.
Although, of course, if you prematurely stem your words, you lose a piece of signal. Like, I don't know, how does English work again?
Exactly.
Yeah, my recollection of taking natural language processing class, it was just like, this is insane. I mean, I love collecting some of these sentences, that I see every now and then. It's I don't know. This one that made the rounds, it was like a picture of like this giant boat, and then on top of the boat were like other boats. It was like this stack of boats and stuff, and there was like this sentence. It was like a ship shipping ships.
Oh,
it was some crazy thing like that, and it's just like, oh god, I've had to parse that. I mean,
here's one for you. Have you ever heard this one? Buffalo, 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 buffalo.
Yeah, I heard. Yeah,
that's a valid English sentence.
Yeah. I sort of wonder, I'm not an AI person, and it's, doing the natural language stuff, there's also a whole like statistical side of that. There's one side where it's like, oh, we're going to parse it according to a grammar. We're going to build structure out of it, almost like what we do with programming languages. But then you have the other side where it's like, we're just going to do statistics on it. And the statistics probably takes you more into things like sentiment analysis and other things, where they just do like a bunch of statistics on the text. On the text, it's like, is the text like positive or is it negative? Are they talking about terrorists or whatever? It's like, yeah, that's not really I don't know how much people are doing like the structural side of that.
A couple of interesting tools along those lines are Spacey from Explosion AI by Matthew Hannibal and Gensim by Radim Jahujek and Rare Labs. I actually did episodes about both of those tools, but yeah, it's definitely interesting hearing more about the idea of natural language processing and, like you said, the sort of conjunction of parsing and statistics to be able to infer meaning from what is, at some level structured, but also inherently free-form in terms of how we communicate using natural language.
No, and speaking of that overlap for our Python using listeners, first of all, if you haven't looked at NLTK and you're interested in natural language processing, go look at NLTK right now. It's fantastic. Great book on it that's free and everything. I see it's full of parsing classes, including a probabilistic context-free grammar parser.
That is definitely interesting. I've been aware of NLTK. I haven't really had much cause to do a lot of work with it, but yeah, it's definitely a well-regarded project and one that has been sort of a cornerstone of the Python community for a while now. So definitely deserving of further interest and investigation for anybody who's out there and working in the space.
Yeah, I'd second that as well.
So are there any other topics about parsing or either of your respective libraries that you think we should talk about?
Well, I have a couple of comments. So this is more of a story. So I recently got a bug report for Ply. Came out of the blue in October. Somebody found this critical bug in like an absolutely essential part of Ply that had never been found. Keep in mind, Ply has been like out there like 17 years, and I'm looking at this bug and I'm like, how is it that nobody has ever found this bug? And the bug came in the form of like a pull request on GitHub. And the person who submitted the pull request, that was the only thing that he'd ever first submitted on GitHub like in 2 years. It was just like this one pull request, this one day on Ply, like for this insanely deep, horrible bug. And it just kind of blew my mind. And the only reason I mention it is that, sometimes it's easy to get into this game of like, like your score on GitHub, like how many pull requests, how many bug reports you've submitted and so forth. And like this one person with like the one pull request in like 2 years fixed this like amazingly hard bug. I just thought it was like amazing. So if anybody's out there wondering, it's like, I wonder if my GitHub score is high enough. Just ignore that. That's all I would.
Imaginary internet points are not going to make you a happy person.
Good advice.
They're not going to be fulfilling in the long run.
No, the only other thing I would say is I've actually rewritten Ply into this new library. Oh yeah, I have this new library called Sly. It's so secret that nobody knows about it. But no, it's no. So when I did Ply, in 2001, there were like all these missing Python features. Like there were no generators, no decorators, no closures. Like it was, frankly, it's just this horrible environment. And Ply has long sort of suffered by not being able to take advantage of that. So the Sly project is basically a re-implementation of Ply, assuming that all versions of Python prior to 3.6 don't exist. So it's basically just like free license to use every insane advanced feature out there. So it kind of takes a different approach, uses a lot of things with meta classes and other exotic techniques. But if you want to go on the bleeding edge, I would look at that.
It's definitely interesting. I'll have to hunt that down and take a peek at it. It's definitely great when you have the opportunity to start fresh from lessons learned, but using a more advanced set of tools to be able to rebuild the thing that you've been struggling with for a long time.
Yeah, it's kind of fun, actually. I've been kind of in a reinvention mood lately, and it's just like I'm gonna redo this thing for Python 3.6 and like forget about backwards compatibility and just sort of see where you can push it. So.
Erik, do you have anything else to add before we start to close out the show?
Well, I'd just encourage anybody with the slightest interest to build yourself a parser or use an off-the-shelf kit because it's a gateway drug to so many interesting computer science subfields. Natural language processing, you could bust out NLTK and play with their stuff. You can do programming language design, start rate compilers and optimizers. And even this is something I seem to do on a repeat offender basis. It's just create custom little query languages. DXR has a little Google-like colony query language. It's an easy thing to do. And, you tend to avoid the sorts of corner cases you do when you're trying to use, split on white space and then do more splits and then regexes. And then you forget you might need quotation marks in something. And so you slap on some kind of escaping thing and before long you made a mess. So parsers for the win.
Talking more about this stuff and thinking about it, I can see a few places in my day-to-day where I'm doing a lot of work with SaltStack and configuration management, where having a parser in place for being able to interpret the the input to SaltStack that then gets regenerated out into another tool chain would be useful. One of the more ugly things is I actually wrote I recall it was a somewhat recursive function to take a Python data structure and then generate a valid Erlang configuration file from it, which was not a fun thing to
do.
Yeah, all right.
Definitely parser.
Yeah.
I think another fun thing to look at if you want to go in a different direction is LLVM.
Sure.
As well. I mean, one thing you can sort of piggyback on top of is the work that the Numba project has done. So
amazing work.
If you haven't seen that, I mean, you can take like Python functions and take them down to machine code using LLVM. But they've actually, like, if you download Anaconda or something, you can actually get the other Python libraries that will let you interface with LLVM, and you can do your own thing, it's kind of insane and awesome at the same time. Like make your own just-in-time compilers and other things. So that might be something to kind of look at too, just to like sort of try to piggyback off that project.
I mean, nobody ever thinks of it, but with a built-in C-types module in the standard lib, you can jump to arbitrary, buffers of machine instructions that you pull together. You're on your own.
I think that's actually how they do it. I'm not sure. I'm not exactly sure on the Numba side. I know you can do it with LLVM, where it's like you can make like a fragment of machine code just sitting there in RAM, and then you can have C-types call it.
Yeah, why not?
And it works. It's cool.
Yeah, and on the front of building your own JIT, now that Pigeon is becoming part of the core language, it's actually something that more people may be inclined to do.
It is?
I believe it got included in 3.6. Last time I spoke with Brett Cannon.
There was like a frame hook or something added.
Yeah.
clearly have to read up.
Is Pigeon the Microsoft thing? There's the Dropbox. What is that? Piston? That's the Dropbox?
Piston is the Dropbox thing, which is a just-in-time compiled Python language VM implementation. Pigeon is the Microsoft project that is an add-on to the CPython runtime that allows you to plug in a JIT, and they have a reference implementation it has a reference implementation that plugs the core CLR JIT into the CPython runtime.
That could be an interesting thing to play with.
Yeah, I was looking at that thinking, I wonder what kind of evil thing I could do with that framework. Yeah, that's probably a topic for another day. That's
right. So for people who want to keep in touch and follow what you guys are up to, I'll ask you to send me your preferred contact methods, and I'll put those in the show notes. And with that, I'll move us into the picks. My pick today is a terminal program that I started using recently called Terminix. I had been using Terminator for a while for its ability to arbitrarily split screens both horizontally and vertically in whatever configuration you choose. And I was becoming stymied by the inability to have an effective find capability where it actually highlights the word that you're looking for. And so through a bit more searching, I found Terminix, which has both of those things as well as a couple of other niceties, including the ability to have it run in a drop-down mode similar to the Quake terminal. So been using it for a little while. Seems to do everything I want. It's definitely been pretty pleasant to use. It's a bit of an upgrade from Terminator, which is another great project. So if you're on Linux, I definitely recommend checking it out. And with that, what do you have for us, Eric?
Well, my pick is somewhat unusual. It's a game from 1997. It's called Riven, and it's a sequel to Myst.
Great game.
Played it back in 97. I got it for Christmas when I was about 2.5 years old or something. I played this thing, and I really enjoyed it. Well, I came back 10 years later and played it again, and boy, it is a work of art. It is more like a virtual theme park or like an epic novel than a computer game. It's pretty much like Myst, except its puzzles are more naturally part of its story. They're not these arbitrary Rubik's Cubes that get in your way.
Yeah, and it's a much larger game as well, so there's more to explore.
It's humongous. The thing was rendered in soft image, which is the same piece of software they used to do the effects in Jurassic Park. And it was rendered as one huge world. It's not like Myst where you're bumping from self-contained age to self-contained age all the time. And so as a result, this thing would take hours just to load in, even on their SGI workstations. In fact, Riven is actually a lost piece of art. They're not able to render it anymore. They're not able to run soft image or whatever it is. They can no longer render it. So all we have today is this these set of dithered 8-bit renderings at like just under 640 by 480. It's really kind of sad, but you can totally play it today under ScumVM if you can get a hold of the original discs, or a little easier, it's available on iOS, and there's even an Android version coming. And then there are these crazy people who are recreating Riven as a labor of love, as not just a kind of clicky through slideshow, but as a 3D real-time rendered thing using the Unreal 4 engine. And they have the full blessing of Cyan, who owns the IP on it. So I'm excited to walk around that when it's finished.
That's pretty cool. Dave, do you have any picks for us?
I'm going to have to figure out some way to split terminals and games here. Well, maybe a bit of both. I guess over the last year, I've been fooling around with this iTerm 2 terminal on the Mac, and one of the fun things about that is it has the ability to display inline images just straight into like a terminal text session. And so I've been using that a fair bit over the last year for things like conference presentations and doing things like injecting impossible font renderings. So I gave a talk in Chicago where I was doing some stuff in the terminal where there were like fonts that were impossible. People were looking, well, like having like, well, like I had like a portion of it. I was like using the Python interactive like REPL, and then I put this thing up and it had like curly braces, like rotated 45 degrees going off at an angle somewhere. And I didn't really say anything about it. I just kind of let it fly, just like nothing going on. What was not realized was that was actually an inline PNG image of a font rotated 45 degrees. So and people kind of come up afterwards. They're like, what were you doing in the terminal? And I made up some story like, well, I'm using some lesser known VT codes, for the, advanced, deck term, not saying that, well, actually those were all like inline images displayed in iTerm. So been having a bit of fun with that. I guess on the game front, I've been wasting way too much time landing Kerbals lately. So if you're into the Kerbal space program game, that's probably single-handedly killed a lot of my productivity over the last month or so. So it's a lot of fun, though. I don't know.
All right. Well, I really appreciate the both of you taking time out of your day to talk to me and share your knowledge and interest in parsers. I've definitely learned a lot from it, and I'm going to have to take some deeper looks at how I might use it in my day-to-day, and I'm sure that a number of other people are going to be inspired to do the same. So thank you both for your time.
It's been a pleasure, Tobias, and likewise, Dave.
All right. Thanks a lot. No, it's fun.